Okay, today we're going to look at some problems from section 2.6, implicit differentiation. And recall that each of these x's and y's represents some other function. And so for each of these, we need to find the derivative. So we're finding the derivative with respect to x for all of these terms. And here, what we really have is the product of x and y. And y is some other function that we don't know, so we have to use our chain rule here. Okay, so going from left to right, the derivative of x squared is 2x minus, so again, as we said, we have the product rule, and I'm going to put that in parentheses. So we have the derivative of x, which is 1 times y, plus, now we have x, and the derivative of y will be y prime, or dy dx, plus, now here, over here, if I wrote this as f of x squared, right, because y is equivalent to f of x, the derivative here would be 2 times f of x to the first power times, using our chain rule, the derivative of the inside, which is f prime of x. So that's in essence what we're going to do every time we see a y. So we would have 2y, and then the derivative, which we'll write using our dy dx notation, equals, and then the derivative of a constant is 0. Okay, so there's all of our calculus. From here on out, we're doing a lot of algebra. So we have a negative 1, in essence, times what's in parentheses, so we're going to distribute. So we have minus y minus x dy dx plus 2y dy dx equals 0. We're going to put, we have our dy dx's. I'm going to move these two terms to the other side of the equation. And from these two terms, I'm going to factor out a dy dx. And we're left with 2y minus x. And then when we add and subtract the other terms, we end up with y minus 2x. Divide both sides by 2y minus x. And so there is our derivative. Okay, so the question actually asks us to find equations of tangent and normal lines to this graph at the point -1, 2. So now we want to find the slope at -1, 2. So we have 2 minus 2 times -1 over 2 times 2 minus -1. So that becomes a positive 2, so 2 plus 2 is 4. That becomes a positive 1. 4 plus 1 is 5. So there's the slope of the tangent line. So using our point slope form down here, we have the tangent line. So we have y minus 2 equals 4/5 x minus -1, which becomes x plus 1. And for the normal line, which remember will be perpendicular to the tangent line, so our slope will be the negative reciprocal. So we still have the y minus 2, so now we have -5/4 x plus 1. All right, let's look at another problem. And here, the question is to find d squared y dx squared, which we know is the second derivative. So we're going to find the first derivative, and then from that we'll find the second derivative. Okay, so we're with respect to x, that's what this tells us. So we have 6x squared minus, so now we're going to do the chain rule. Again, over here, if we had 3 times f of x squared, right, the derivative, 2 times 3, 6 times f of x to the first, again, times the derivative of the inside, so there's our chain rule. So applying that here, we would have 6y dy dx, and again, the derivative of a constant is 0. So we'll subtract 6x from both sides, divide by the negative 6y, and dy dx is equal to x squared over y. So there's our first derivative. Now we're going to find the second derivative. And so we're going to use our quotient rule. So d squared y dx squared. So we have y, the denominator, times the derivative of the numerator, which is 2x, minus the numerator. Now the derivative of the denominator y is just dy dx divided by the denominator squared. So we have this dy dx, and we're going to substitute the original dy dx in there. So we have 2xy minus x squared times x squared over y times y squared. Again, we have our nested fractions. So similar to what we did back with when we were doing limits with nested fractions, we're going to multiply by the common denominator, which is y. So again, distributing, we get 2xy minus the y's divide out. We get x to the fourth, and then in the denominator we end up with a y cubed. And so there is our second derivative. This should have been a y squared. My apologies, right? Y times the y is y squared. So 2xy squared minus x to the fourth over y cubed. Okay, one more. Here we're going to involve trig. And so now we're going to find the derivative of this expression, or this equation rather. So going left to right, the derivative of x is 1 plus, so again we have a composite because it's the sign of a function. Right? So again over here, if we use different notation, if we had the sign of f of x, right, the derivative would be the cosine of f of x times the derivative, which is f prime. So applying that here, we would have the cosine of y times dy dx equals, on the right side we have our product rule. We did one of these, I think xy, in fact, exactly in the first problem. So we have the derivative of x is 1 times y plus x times the derivative of y, which is dy dx. So now it's a matter of putting everything on the same side. Doesn't matter which side you want to go to. So I'm going to subtract the x dy and subtract the 1. So getting a little ahead of myself there. So we have the cosine of y dy dx minus x dy dx equals y minus 1. We'll factor out a dy dx from both of those terms. And lastly, divide by the cosine of y minus x. And we end up with y minus 1 over cosine of y minus x. All right, so there's three examples where we're using implicit differentiation. Hope that helps, and we'll see you soon.